So let's take a look at some examples up here. We have, on our reactant side, we have a metal right here. And is it all alone when it's on the reactant side?
Copper looks all alone right there.
Yeah, I think it's all by itself. It's a free element. So let's go ahead and put a little blue box around copper. And what's it doing over here on the product side?
Well, this looks like it's undergoing a single replacement,
Mm-hmm.
and it's replacing the silver, and it's going into a compound. So it's going from being a solid metal on a reactant side to being an actual compound with that metal in it.
Right. So it was alone, and now it is part of a compound. And then with the non-metals, or actually we don't have really non-metals in here. I mean, we do, but like none that were like alone by themselves.
We're dealing with the polyatomic there.
We're doing the polyatomic, yeah. So right here, we do have something that is being reduced, and we have something being oxidized. And so it is a redox reaction.
And in this case, we know it's a redox because the silver is going from in a compound to out of a compound.
That's right.
So it's kind of the other side of it too, if you wanted to look at it that way.
Yep. We have one thing that was by itself, and now it's part of a compound, and we have another thing that was part of a compound, and now it's by itself.
Mm-hmm.
So it's definitely a redox reaction. And what is being oxidized? Which thing went from being alone to now part of a compound?
Well, the metal went from being alone to in a compound.
Mm-hmm.
And when, I think it said at the top, when metals do that, it is oxidized.
We're looking at that right there.
Yeah.
So when metals are alone and then part of a compound, they are being oxidized. So we can go ahead and say that's being oxidized. What's being oxidized? The copper.
Copper, yeah.
Right. And then what's being reduced?
Well, again, at the top, you told me that when it's part of a compound and then it becomes alone, that's reduced.
Right. So the silver in this case is being reduced. They're both metals, and they both have something going on with them. Where one's by itself and then part of a compound, the other's part of a compound and then by itself. So we have oxidation and reduction both going on right here. Let's take a look at the next example. In this equation right here, this chemical reaction, we have single replacement again. That's what it looks like to me.
Yeah, looks like single replacement. Looks like the bromine is taking the place of the chlorine.
Oh, there we go. So we have something that is by itself right here.
And this time it's a nonmetal.
It is a nonmetal, and now it's part of a compound. So whenever nonmetals do that, they're alone and then part of a compound. Right here.
So then they're reduced.
They are reduced. And whenever we have a nonmetal that was part of a compound and now it's alone, which is the case of the chlorine right here. The chlorine is part of a compound, and now it's by itself.
Mm-hmm.
That one is being oxidized.
So that's oxidized. Gotcha.
So we have both happening right here. So this is definitely a redox reaction. Yes, it is. And what is being oxidized? The thing that was that was part of a compound and now is alone, so the chlorine is what's being oxidized. Right?
Mm-hmm.
So which one is being reduced?
It's got to be the other one. It's got to be the bromine.
Yep. If we're following those rules up there, it's pretty easy to figure it out. Okay, let's take a look at one that's a little bit weird. We have two things that are alone, and now they're part of a compound.
So this is a synthesis.
This is a synthesis reaction. We have two single things that come together to make a new thing. So yeah, that is a synthesis reaction. How are we going to figure out which one is being oxidized and which one's being reduced, or if that's even happening?
Well, even though they're by themselves, we can still go by the rules above, because the metal on its own, it's on its own at the beginning, and then it's in a compound.
Oh, you're right.
So
now it's part of a compound. So that, if it's alone and now it's part of a compound and it's a metal, that means that it's being oxidized. So the aluminum is being oxidized right here. Okay, so then for a non-metal, which is the oxygen, that was alone and now it's part of a compound.
So it's got to be reduced. I guess because
You're
they're just opposites of each other. That whenever they bond that way, the non-metals take the electrons and metals give it away.
The metal's giving away its electrons, so it's losing, so it's being oxidized, and then the non-metal is gaining electrons, so it's being reduced. So this is a redox reaction.
Yeah, so oil rig would help us out here.
Oh yeah,
oxidation
definitely.
is loss.
So now we have another kind of funky one. What type of reaction is this?
Oh, well, I don't really see anything being cleanly replaced. Aha, there's O2 on the left. We have CO2 and H2O as products. Probably going to be combustion reaction.
It is a combustion reaction. Combustion reactions always have CO2 and H2O as products. And they involve oxygen in one way or another. So I see right here that we have a non-metal that is alone, and now it's part of a compound, so that rule still applies. So if we have a non-metal that was alone, and now it's part of a compound, that's being reduced. So oxygen is being reduced again, in this case.
So, but this is so strange because we don't really have a metal here.
We don't. We don't have a metal. And we also don't have a non-metal that was part of a compound and now it's all by itself.
But we did have a non-metal that was by itself and formed a compound. So we know we're probably looking for something that's being oxidized.
You're right. It's just the trick is figuring out which one it is. I know that with hydrogen, we got hydrogen right here. Hydrogen always has a +1 charge, right? So redox always involves a change in oxidation number, which we didn't really talk about a whole bunch, but if something's losing electrons and something's gaining electrons, its oxidation number is changing. Hydrogen is neither losing nor gaining any electrons right here. It's not changing at all. So that is another thing to definitely keep in mind. What we have right here is kind of a funky reaction where hydrogen.
So hydrogen's always a +1.
Hydrogen's always a +1. So.
Well, if hydrogen's a plus there, then that means that the carbon is a minus.
You're right. So we can make a note right here. Hydrogen doesn't lose or gain electrons. Right, so it doesn't change.
Oh, you know what I just remembered? Carbon's one of those weird ones that the charge can be plus or minus.
You're right, you're right.
Go either way.
So over here we have a carbon that has a negative charge because it's combined with this positive hydrogen, and then over here, when it's combined with oxygen, it's got a positive charge.
Because oxygen's negative.
You're right. So
okay. Because
hydrogen didn't change, we now know that carbon had to have been the one that was losing its electrons. Right. So since carbon was losing its electrons, that's the one that was being oxidized.
So it went from, in the CH4, in the methane, it went from taking the electrons to being with CO2 where it's giving the electrons. So it switched. It did. It just switched all of a sudden. It switched all the electrons all at once. Wow.
Over here it was a -4 charge, and over here it's a +4 charge. So carbon clearly lost its electrons there. So that is the one that is being oxidized. So this is a redox reaction.
That's a weird redox.
It is a weird redox reaction. But if you can remember that hydrogen just doesn't change, then whatever non-metal was in that compound with hydrogen would have been the one that was either losing or gaining electrons, right? So if it's not hydrogen, then it's the other non-metal. Okay. So there's a lot of rules, but if you can follow these rules and keep those in mind, then it's pretty simple, pretty straightforward.
Yeah.
If you guys have any questions, be sure to talk to your teacher.